All right. Number 25, we got f of x equals to 2 sine of x plus sine of 2x. 2 sine of x plus sine of 2x on 2 pi. Was it inclusive of 2 pi or not?
Yes.
It was inclusive, okay. And the question is, what's the question asking you?
We're just,
One of them.
yeah, point of inflection.
Point of inflections, okay, thank you. So f prime equals to
2 cosine x.
2 cosine of x.
Coach, I'm gonna be like 10 minutes late.
2 plus 2 cosine 2 of x.
Plus,
Savannah and Stephen Cole, please come to the front office.
Holy
They
crap.
found her dog.
okay. F double prime equals to
Negative 2 sine x plus 4 sine 2.
Minus
minus 4
Minus 4, yeah, I have a
sine
minus.
of 2x.
I have a plus minus.
Okay, that works. Okay. All right. I think if you don't transform that one, you can't solve this problem. Sine of 2x is actually, I gave you a trig cheat sheet way back when we first started, like the very first day. Sine of 2x is actually 2 sine of x cosine of x. So that's 4 times 2 sine of x cosine of x. Are you following me? Are we okay with that?
Right.
Sine of 2x. Trig transformation. You have to have that trig transformation going right there. So sine of 2x. This is the cheat sheet I gave you. Okay?
Yeah.
Sine of 2x is 2 sine of x cosine of x. You see that? Great. So I replaced that with this. So that is f double prime equals to negative 2 sine of x minus 8 sine of x cosine of x. Why do I have to do that? Because I can't set this equal to 0 and solve it. I have to have a set of
2.
basically I factored out where I have binomial pairs that I can set equal to 0. Okay? So out of here I can undistribute a what?
Sine.
Sine of x. So I could take out a negative 2 sine of x. I don't know if it would matter or not. I think I will. Negative 2 sine of x, leaving behind
1 plus
1 plus
4 cosine of x.
4 cosine of x. I can set that equal to 0, and that one's going to be easy. Sine of x equals 0 at
0.
and pi, right?
And 2 pi.
0 pi and 2 pi. Okay, that's that one. This one, 1 plus 4 cosine of x equals to 0 gives me negative 1/4 equals to cosine of x. I don't know when cosine of x is a negative 1/4. That would have to be a calculator problem at that point.
They had decimal entries.
Okay.
They just didn't have.
Yeah. So basically what I'm looking for is the I could do arc cosine of
Negative 4.
negative 1/4, but that's not going to give me every answer, I don't think. That's just going to be the first answer. So
So you have
second,
to add pi to that maybe?
1/4. So it'd be 1.8.
I think you had to add pi.
It would probably be Maybe down here. I tell you what I would do, because I'm struggling with what it would be. I would graph it. I would say, where does y equals to cosine of x have a y coordinate of negative 1/4? Is that correct or not? Is that what I'm wanting? So on 0 to 2 pi, let me zoom in here. Let me make my window. Let's do our y min negative 1, y max 1. There we can see it better. Okay. So trace, second trace intersect, boom, boom. The first one should be this one right here at 1.8, which is what our calculator gave us, right? Everybody see that? The next one's right here next to it, second trace intersect, boom, boom, a little closer, 4.45. Is that bigger than 2 pi? 2 pi would be 6 point something, wouldn't it? Yeah, so that's within range.
I'm sorry.
Yes, ma'am.
I'll make this very quickly. I just was informed that we're having workers on transfer profits for annual art.
Good.
If you could just give
Sure.
me anything, I'm sorry to
No
interrupt
problem. What do you
everything.
What do you
Monday.
got? Okay.
Thank you.
Yep.
I'm so sorry. I
fine.
was trying to get it out earlier.
Okay. All right. And so the last one, right here, that may be outside the domain. Second trace intersect, boom, boom, come over here. That one's outside the domain. So just these two right here. So the 1 point, what were they again?
1.823.
1.8, what was the other one? 4.4 what?
4.6.
Okay, we call it 4.4 for right now. Okay? So those are your intervals you have to check on. Do you need to keep checking? You okay with that? Those are your candidates for points of inflection.
And you plug them into the 2 sine x, or negative 2 sine x plus negative 4 2 sine 2x.
You can plug them into this one right here. But the calculator won't matter by hand. It's easier to plug it in. Always plug in that one that you've factored out. Okay? What else?
Can you like show how to do like one of the graphs?
Which one are you on?
Like maybe
53.
54.
54? Okay. All right, 54.
Zero, 0, 0, and 2, 0.
So f of 0 equals f of 2 equals to 0. So f of 0. So f of 0 equals to f of 2. All of those are zeros, right? So those are y coordinates of zeros right there. Sorry, I didn't draw that very good. Let's try to draw that a little better. There's my x-axis. So I have a 0 there and a 0 there. All right. I know that f prime is positive if x is less than 1. I'm trying to graph the sketch of f, correct? If f prime is positive, that means the graph is what? Increasing. The graph is increasing for everything left of 1. The graph is increasing everything left of 1. So I'm going to come back to that in a second. I know that f prime at 1 is 0. F prime at 1 is 0.
So that's going to be a maximum.
F prime at 1 is 0, so that's going to be a max or a min.
That's as far as I got it.
Okay, so f prime is less than 0 for x bigger than 1. f double prime is less than 0. Since f double prime is less than 0, this entire thing is concave down. The entire graph is concave down. We know that for a fact. So f double prime less than 0 tells us it's concave down. F prime of 1 is 0, which means that has to... Oh, 1, that's right, okay. F prime of 1 is 0. So it's increasing...
So the 1 is the max, right?
Yeah, the 1 is the max. I don't know where the 1 is on the graph. I have no idea where that is on the graph.
You know it's the max.
I just know it's a max, and I know wherever it is, I'm going to put it right here so I'm picking out of the sky. I know it's the max. I know wherever it is, it has to come down through these 2 points. Those are my x-intercepts. So it could be up here, it could be right there, doesn't matter. The point is, that's my max. I have my x-intercepts, and it's concave down the whole way, which means it has to be some sort of quadratic shape like that. Okay? Something like that. Any of that's fine. That make sense?
Yeah.
Anything else?
We're ready to learn.
Go over,
I'm at 55.
yeah, why has the
55. All right, f of 2 equals f of 4 equals to 0. F of 2 equals f of 4 equals to 0. F prime is bigger than 0 if x is less than 3. So it's positive slope, okay? F prime of 3 does not exist. Come back to that in a second. F prime is less than 0 for x bigger than 3. So there's that one, okay? I know those two things are happening right there. F prime of 3 does not exist, so that could be a hole. It could be an asymptote. F double prime is bigger than 0. Did I read this wrong? I read it wrong. F prime is bigger than 0 if x is less than 3. No, I didn't. I read that right. Bigger than 0 if x is less than 3. Okay, so yeah. So here's what's going to happen. This right here tells me this f double prime bigger than 0. Tell me it's what? Concave up. That means these have got to look like this. Concave up, right? You follow me? Which means this can't, I guess it still could be a hole technically. More than likely this is a what?
Cusp.
It's not a cusp because it doesn't, well, I guess it could be. F prime of 3 does not exist, so it's not a cusp. No? It could be a cusp.
F prime of 3 means there's no slope, there's no like, yeah.
It's either going to be a hole, a cusp, or an asymptote. Any of those 3 are possibilities.
They did a cusp.
They did a cusp.
Cusp.
Could be an asymptote as well. All right? There's nothing here that tells us for sure what's going on. But it's coming up like this. It could be a cusp, could be a hole, could be an asymptote. Any of those 3 are possibilities.
Understandable. Have a nice day.
Other questions?
Yeah, we should write out the equation that we make that.
Soon, Alex, soon. In time, my brain.
If you had a piecewise function, it could be 2 quadratics. If you kept it simple, it could be x minus 2 squared minus 3 and x plus 6 squared minus 3. You put a restriction on the domain, and that would make that graph. show you. X minus 2 squared minus 3. So that'd be plus right there. And then x plus 6 squared minus 3. I've got them backwards, but you can see right there,
Where we do
if I
that.
put a restriction on the domain, right? I restricted this one to one piece of another piece, that would be a cusp right there.
Correct.
If I restricted those as well, you can see that there we would have kind of the same shape we're talking about. Concave up, coming to some sort of cusp in the middle. So this part right there would be the, okay. Okay, so today we're going to do some more graphing. Just want to refresh your memory here. F is the position, F prime is the speed, F double prime is the acceleration of that object. All right? So as you're given these things, they're just talking about what's happening to an object in space. We're going to be doing a lot of graphing. So you guys were asking about those graphing problems. You get a chance to practice today. We're doing the even ones. You need to find these values for doing the even ones, and we're going to graph them. That's why you have the graph paper. If you don't have the graph paper, did you have the graph paper yet? I didn't. Yeah. All right, so number 2, there are no intervals, I mean no asymptotes, so A is done. On B, what do you have to do?
You have to derive.
You got to derive to get where it's increasing or decreasing. And while you're doing that, you might as well go ahead and do D and find the relative max and mins.
Plug in the x values to the original equation.
Yes, sir. So F prime is going to be 4x cubed minus 36x. Is that correct? So that equals to 0. And you take out a 4x out of that, leaving behind x squared minus 9. Is that correct? Okay. And this is difference of squares, so 4x times x minus 3 times x plus 3. My critical points are -3, 0, and 3. Critical points, x equals -3, 0, and 3. Alright, pick a number left of -3. I'll pick -4. Negative, negative, negative. Looks to me like that's going to be a negative slope. Do you all agree with that? Am I going too fast? I stuck a -4 in this equation right here. Negative here is going to make that negative. Negative is going to make that negative. Negative times negative is positive. -4 here is going to make that negative. Positive times negative is going to be negative. So my slope is negative. Plug in a -1. Negative, negative, positive. So that's going to be a positive slope right there. Stick in a +1. Positive, negative, positive. That's a negative slope.
I thought we were supposed to put the numbers, like the -3, 0, and 3 on the line.
In where?
I thought we were supposed to put like the critical point numbers on the line. And then-
These are my critical points down here.
Yeah, I
Those are-
thought those were the ones you were supposed to put on the line.
Put on this line right
Like
here.
in the line,
You can do it however you want to. I'm picking values around them so I can test if we're increasing or decreasing. These are going to be zeros.
yeah. I don't know, I thought there was a certain way you had to put it on the line.
This is the way I'll do it every time. Okay, because these are the critical points. These are my critical points I'm testing. The numbers on the line I'm putting around it are just the ones that are going to allow me to do the test. So +4, positive, positive, positive. So this graph is decreasing from -infinity to -3, and from 0 to +3. This graph is increasing from -3 to 0, and from 3 to infinity. This graph has mins, relative mins, at what? At -3. Go find your y value in the original equation. -3 and 3. Everybody see why? Negative slopes coming down, positive slopes going up, so there's a min here. Negative slope coming down, positive slope coming up, so there's a min here. Everybody follow me? Okay. Plug in the original equation. So -3 to the 4th power, it's a +81, minus 18 times 9. I don't know that one. Negative what?
-81.
-81. Okay. Now do the other one. Should also get -81, shouldn't you? Okay, so there's your relative mins. Your relative max. It's gonna be at what point?
0, 0.
0, 0. 0, 0? I guess it would be, wouldn't it? 0, 0. Relative max at 0, 0. So here's your max right here. It's coming up and then coming back down. So there's your max right there. So that's B and D. I'm not sure why those are separate, but that's B and D right there. Okay?
So we gotta derive again.
Part C, you have to derive again. Part C, you want concave up or concave down. So F double prime equals to 12x squared minus 36, is that correct? Okay, so that's 12 times x squared minus 3. It's a weird number. So my critical points are going to be at plus or minus square root of 3. Okay. So plus or minus square root of 3. So square root of 3, negative square root of 3. A number left of negative square root of 3. Negative 2. So negative 2, plug a negative 2 in this, that becomes a positive 4. So all of that is positive. Number between negative square root of 3 and square root of 3?
0.
0. Okay? 0 squared 0 minus 3, that's going to be negative. And a positive 2, positive. So we have 2 points of inflection. So first off, it is concave up from where to where? Negative infinity to negative square root of 3 and
Square root of 3.
square root of 3 to infinity. It is concave down.
Negative square root of 3 to the square root of 3.
Negative square root of 3 to square root of 3. Okay. All right. It has points of inflection. So this is going to be E. So this is C and E. So points of inflection at again, you're taking these back up into your original equation. You'll definitely have to calculate for that, I would think.
So it would just be 27.
27?
Well, no, like negative square root of 3.
Negative square root of 3 to the fourth power is going to be 9.
9.
Yes. Minus 18 times 3. That's 50. No.
Negative
Negative what?
45.
Negative 45. Everybody agree with that? And the other one's also going to be negative 45? Okay. F says X and or Y intercepts. That's going to come out of the original equation. So I'm going to factor that guy out. And so his x-intercepts are going to be
Zero and plus or minus 3 square root of 2.
plus or minus square root of 18, which is 3 square roots of 2. Which if we're going to graph is approximately what? 3 square root of 2. Approximately 4.2. Those are your x-intercepts. Your y-intercept is going to be
0, 0.
0, 0. Okay. The last part is to graph that all that mess. Okay, I'm going to use, since our numbers are so big, I'm going to use every tick mark is 5. No, every tick mark's 10. Every vertical tick mark is going to be 10. Okay, it's negative 81, right? That means horizontal tick marks of 1, verticals of 10. That make sense? You okay with that?
Horizontals 10.
Horizontal's 1.
Horizontals 1 over.
Yeah. So let's plot our x-intercepts and our y-intercept. Our y-intercept is 0, 0. Our x-intercept was 0, so that was already there. Plus or minus 4.2. So 1, 2, 3, 4.2. 1, 2, 3, 4.2. So that's F. I'm done with F. All right, I need to plot the maxes and the mins. We had relative mins at negative 3, negative 81, 10, 20, 30, 40, 50, 60, 70, 81. And positive 3, negative 81, 1, 2, 3, 10, 20, 30, 40, 50, 60, 70, 81. So there's my relative min. And we're going to put a little cusp on these, or a little cup on those, so I know I'm coming up from my relative mins. Okay? I had a relative max 0, 0. So I'll put a little hill right there. I'm done with BC. Now I'm going to deal with the points of inflection. Negative square root of 3, negative 45. Well, negative square root of 3 is 1.7, I think, something like that. Okay? So negative 1.7, 45, 10, 20, 30, 45. So I go from concave up to concave down right there. And positive square root of 3, 10, 20, 30, 45, right there. I have everything I need now. Okay? I'm concave up from negative infinity to negative square root of 3. That's that left-hand U right there. I'm concave down from negative square root of 3 to positive square root of 3. I'm concave up from negative positive square root of 3 to infinity. And I'm done. Sir?
Made it W
Made a W.
upside down.
That was a big fat problem.
That's a big fat problem. Go to number 4.
There's just some hallways. Yeah, I'm way here looking. I don't know how to get them.
That took me like almost a page and a half.
Yeah. You might want to do all your work on regular paper and then graph on these.
Oh, it's too late.
Same from now on.
These are all mine.
Nope.
So is it just 2 through 8?
There is 15, so 2 through 14 even.
Two through 14?
Yeah, so yeah, 2 through 14 even, yeah.